This is 4.3.3 Newton law of cooling, applications of separable equations. So, according to Newton law of cooling, the temperatures of an object changes at a rate proportional to the surrounding temperatures. If the capital T is the temperatures of the object at time t, then you have these differential equations, and the K here is referred to the cooling constant, the capital T here is referred to temperatures of object, and the capital TS is referred to the temperatures of surrounding, and the small letter t is referred to the time. Okay, let's look at the first example. A thermometer reading 120 degrees Fahrenheit is placed into a refrigerator that has temperatures of 35 degrees Fahrenheit. If after 5 seconds the temperature reading on the thermometer is 60 degrees Fahrenheit, what is the temperature of thermometer after 10 seconds? Okay, the first thing that you have to do is you have to figure out what is the information from that we can extract from this example. Okay. First thing that is you have to figure out the temperatures of the surrounding. For this example, the temperature of the surrounding is referred to the temperatures of the refrigerators. So mentions that the refrigerator has the temperature of 35 degrees Fahrenheit. This is basically your temperatures of the surrounding. That is your TS. Your TS is actually 35 degrees of Fahrenheit. Okay. Now, next thing is you have to figure out what is the initial temperatures. Okay, so initial temperature is referred to this 120 degrees Fahrenheit. This is your capital T. Okay, at the time equal to 0, that is your initial temperatures is 120 degrees Fahrenheit. Okay, it mentions that if after 5 seconds, that is your time. Okay, the temperature reading on the thermometer is 60 degrees Fahrenheit. This is actually your capital T at the time equal to 5 seconds is equal to 60 degrees of Fahrenheit. This is your third information. So what is the questions of this example? So these questions, the questions of this example is actually asks us to figure out what is the temperature, of the thermometer after 10 seconds. That is your time equal to the 10 seconds. So what is this one? Okay, so this is the questions for the example 1. Once we have gathered all the information from this example, let's just begin to solve it by using the differential equations of the Newton law of cooling. That is this one. Okay, now let's just begin by substitute the value of Ts into this differential equation. So what is your value of Ts? So this is your value of Ts. So your value of Ts is 35 degrees Fahrenheit. So this is actually 35. Okay, substitute into this one, so we will have the next time. Okay, now what you have to do is you have to bring this t minus 35 to the left hand side. If you bring to the left hand side, it becomes 1 over t minus 35 together with the d capital T. And how about the right hand side? For the right hand side, you will have the k together with the d small letter t. Okay, now integrate both sided. Okay, if you integrate both sided, for the left hand side, you will have ln. For the right hand side, you will have kt plus c. Okay, exponent both sided. Okay, so this is what you have for the next line. Okay, for the exponent, you can split into 2. So if you split into 2, so you will have e to the power of kt and e to the power of c. And the ec here is a constant, so you can replace it with the constant a. And you can bring this minus 35 to the right hand side. Then we have the next line. So let's just name it as equation number 1. So if you look at the equation number 1, basically you have two parameters that you have to figure out the value. That is the parameter a and the parameter k. So how are we going to figure out this value of parameters? It's through the information. So let's look at the first information that we have here is that T0 equal to 120 degrees Fahrenheit. So we're going to substitute it into your equation number 1. So let's just substitute it. Okay, so this means that your temperature is 120 degree of Fahrenheit. So 120, we're going to substitute here. And the time is actually 0. So the time is actually 0. We're going to substitute here. Then we have the next line. So simplify it, you're going to have your A is actually 85. Now you know your value of A. Substitute your value of A into your equation number 1. So substitute here. We're going to have the next line. So let's just name it as equation number 2. So you can see that we already figured out the value of parameter A. The next thing is you have to figure out the value of parameter K. So how going to figure out the value of parameter k? That is through these third informations. So you have the third informations here. So you have the T, capital T, at the time equal to 5 equal to 60 degree of Fahrenheit. So you're going to substitute into your equation number 2. So you substitute into equation number 2, you're going to substitute your temperature as 60 degree into here. Your time is 5 into here. So we're going to have the next line. Okay, so bring this 35 to the left hand side, it will become minus. You have 25, okay, and you will have 25 divided by 85, so you have 5 over 70, and now you're going to ln both sided, okay. So now you take ln 5 over 17 divided by 5, then you have your value of k. So once you obtain your value of k, you're going to substitute into here, into your equation number 2. So if you substitute into your equation number 2, this is what we have. Okay, so let's just name it as equation number 3. So this equation number 3 is basically the mathematical equations for us to predicting the temperatures of the thermometer at any time t. So now we're going to use these mathematical equations in order to answer these questions. So the question says that what is the temperatures of the thermometer at the time equal to 10. So we're going to substitute this one into your equation number 3. So it means that your time is actually 10. So we're going to substitute time is 10 into this equation. So use your calculator to get the value. So you have the temperature is actually 42.3496 degree Fahrenheit. So this is basically the temperatures of the thermometer after 10 seconds. Now we come to the second example. So a cup of freshly pulled coffee has temperatures of 80 degrees Celsius. It is served in a room that has constant temperatures of 25 degrees Celsius. And in 1 minute later, the coffee has cooled to 60 degrees Celsius. Determine when will the temperatures of the coffee reach 30 degrees Celsius. Okay, so let's just extract the information from this example. The first thing that you have to figure out is the temperatures of the surrounding. So if you refer to this example, this basically refers to the temperature of the room. It says that it has the constant temperature of 25 degrees Celsius. So this is basically your TS. So your capital TS is equal to 25 degrees Celsius. Now, the next thing we have to figure out is the initial temperatures of the coffee. The initial temperature of the coffee is 80 degrees Celsius. This is your capital T. At the time equal to 0 is equal to 80 degrees Celsius. Okay. Then it says that in 1 minute later, this is your time. Okay. The coffee has cooled to 60 degrees Celsius. That is your capital T. At the time equal to 1 minute is equal to 60 degrees Celsius. So this is your third information. Now what is the questions for this example? The questions ask us to determine when will the temperatures of coffee reach 30 degrees Celsius. So when will means that we are interested to know the time. So what is the time? So the temperature of coffee reached 30 degrees Celsius. Okay, mathematically you can write it in this way. The temperatures at the time is actually unknown, is equal to 30 degrees Celsius. So this is for the example 2. And once we have gathered all the information that we have in the example 2, let's just begin to solve it. Okay, so let's just begin with the differential equations. Okay, the first thing that you have to do is you have to substitute the value of Ts. So what is your value of Ts? Your value of Ts is actually 25. Put you substitute your value of Ts into here. So this is 25. So you have the next line. So now, okay, bring this t minus 25 to the left hand side. You will have 1 over t minus 25 together with the dt. Okay, and then for the right hand side, you will have k together with this dt. Okay, integrate both sided. So for the left hand side, if you integrate, you have ln. For the right hand side, you have kt plus c. Okay, exponent both sided. Okay, and then simplify it. Then you will have your equation number 1. And same thing here, so it means that you have two parameters that you have to figure out the value. That is the parameter a together with the parameter k. So how to figure out that? Okay, so that is through the information. So let's just look at this information. So we have we have this T0 equal to 80 degrees Celsius. So let's just substitute into your equation number 1. So it means that your temperature is actually 80 degrees Celsius. So we're going to substitute into here. And what is your time? Your time is actually 0. So substitute into here. We're going to have the next line. Okay, so simplify it. You will have your A is actually 55. Okay, so once you have known your value of A, so substitute your value of A into your equation number 1. So you're going to have the next line. So now, we have figured out the value of the parameter A. Then let's just figure out what is the value of parameter K. So let's just name it as equation number 2. Okay, so we're going to use the second equations that we have here. So that is T1 equal to 60 degrees Celsius. Okay, so we're going to substitute into equation number 2. So let's just substitute this one. Okay, temperature is at 60 degrees into here. And your time is actually 1 into here. So then this is what we have here. Okay, so you have 60 minus 25 will give you 35. Okay, so 35 divided by 55 will give you 7/11. Okay, and log both sided. Okay, so then you will have your value of K. Your value of K is negative 0.4520. Okay, and now substitute your value of K into your equation number 2. So if you substitute into equation number 2, this is what we have here. Okay, so that's the same as equation number 3. So this equation number 3 will be the mathematical equations for us to predict the temperatures of coffee at any time. So let's just look at the questions. So the questions ask, okay, when will the temperatures of the coffee reach 30 degrees Celsius? So we're going to substitute this one into your equation number 3. So let's just substitute into equation number 3. So it means that you're going to substitute your temperature as 30 degrees. So substitute 30 degrees into here. So we have the next line. So you have 30 minus 25, so give you 5. Okay, 5 divided by 55 will give you 1/11. Okay, log both sided. So then, okay, so you have log 1/11 divided by this negative 0.4520. We'll give you a value of T, so your value of T is 5.3051 minutes. This means that after 5.3051 minutes, the temperature of coffee will reach 30 degrees Celsius. Now we come to the third example. A man was found murdered in Genting Highland. It was a cold day with temperatures of 15 degrees Celsius. At noon, Detective Arif reached the crime scene and started to measure the temperatures of the corpse, which was found to be 32 degrees Celsius. He measured the temperatures of the corpse again at 1 p.m. and found that the body temperature was 30.2 degrees Celsius. What is the time of death? Let's just extract the information from this example. Okay, the first thing that you have to figure out is the temperatures of the surrounding. So the temperatures of the surrounding was 15 degrees Celsius. So this is basically your TS. So this is your TS. The TS is 15 degrees Celsius. Okay, and it mentions that at noon. So it means that it is 12 p.m. So this is your time, okay? Your time equal to 0, your initial time. So detective measures the temperature of the corpse, which was found to be 32 degrees Celsius. This is actually the temperatures at the time equal to 0 is equal to 32 degrees Celsius. Now that is what we have. Okay, and then he measures again, okay, at 1 p.m. So at 1 p.m. that is your time. It's actually equals to 1 hour. Okay, so he found that the body temperature was 30.2 degrees Celsius. That is the temperatures at time equal to 1 hour is actually equal to 30.2 degrees Celsius. Okay, so that is what we have for the informations. Okay, what is the time of that? That is our questions. So I'm interested to know the time. Okay, that is your T is actually a question mark. Okay, your time of that. Okay, your T is actually a question mark. So how do I know that okay, when was this man was killed, okay, that is through the temperatures of the body, okay. So the temperature of the body of this man was killed was actually still equal to 37 degrees Celsius. Okay, we're going to trace back the times that this man was still having a normal body temperatures. That is, your temperatures at the time t is still equal to 37 degrees Celsius. Okay, so that is what we have. Okay, so for the questions, okay, perhaps the timeline will help us to battle on to understand this problem. Okay, so let's just have a timeline. Okay, so let's just draw a timeline. Okay. So, okay, Detective Arif, okay, measures the temperatures of the body actually at the 12 noon. So that is, there was 32 degrees Celsius. Okay, after 1 hour, it became 30.2. Okay, when we wanted to know when was the time of that, okay, that is the time that this man was still having a normal body temperature, so it's 37 degrees Celsius. So we're going to trace back the time, okay? So if we look at this time now, you know that your t is supposed to be in terms of negative because you have traced the time backward. Okay, let's just solve this example number 3 through the differential equation. So we can substitute the Ts, okay? So your Ts is actually 15. So then we have the next line, okay, bring this t minus 15 to the left hand side such that it is together with the dt. Okay, so you have 1 over t minus 15 together with dt. Okay, and then bring this dt to the right hand side such that it's together with the k. And then you learn both sided. Okay, so then when you learn both sided for the left hand side, you have ln, for the right hand side, you have kt plus c. Okay, exponent both sided. Okay, and then simplify it, so you have the first equations. Now figure out the value of the parameter a and the parameter k. Okay, so how to figure out? First, through the information. So the first information that we have is t0 equal to 32. So we're going to substitute t0 equal to 32 into your equation number 1. It means that you will substitute your temperature as 32 into here. And your time is actually 0 into here. So we have the next slide. Okay, we'll simplify it. You have your value of a is actually 70. So once you have known your value of a is 17, substitute your value of a into your equation number 1. So if you substitute, then this is what we have. Okay, let's just name it as equation number 2. So the next task is figure out the value of the parameter k. So let's just use these informations. T1 equal to 30.2. So let's just substitute into your equation number 2. So your temperature is 30.2, okay. And your time is actually 1. Substitute into here. So that is what we have here. So 30.2 minus with the 15 will give you 15.2. And 15.2 divided by 17 will give you 0.8941. And ln both sided. Okay, and you will have your value of k that is negative 0.1119. Okay, substitute your value of k into your equation number 2. Substitute here. And then this is what we have. So this is your third equations. Your third equations is the mathematical equations that we're going to use for predicting the temperatures of the cups at any time. Okay, let's just figure out, okay, what is the next thing that we should do. Okay, that is, we're going to answer these questions. Okay, when was this man was killed? Okay, so they're going to substitute this one into your equation number 3. So it means that you can substitute your temperatures as 37 into your equation number 3. So this is what we have. Okay, 37 minus with 15 is basically give you 22. So 22 divided by 17. Okay, and then you will ln both sided. Okay, ln 22 over 17 divided by negative 0.119. You will have your value of t. So your value of t is negative 2.3041 hours. Okay, change 0.3041 into minutes. Okay, so multiply it with 60 minutes. So this is give you 80 minutes. Now we know your time. So your time is actually in terms of negative 2 hours 80 minutes. Okay, so let's just refer back to our timeline. Okay, So now your time of that, okay, so your t is actually negative 2 hours 80 minutes. Okay, how would you know when was this man was killed? Okay, so go to trace back, okay, from the initial. So your initial is actually 12 noon, okay, at 12 noon. Okay, so at 12 noon, so we're going to minus this 12 noon with this t, so that is negative 2 hours 80 minutes. We will minus it. So if you minus, okay, we have 9:42. So this means that the time of that is 9:42 a.m. Okay, so at the morning of 9:42 a.m. this man was killed.